Hi, everyone. I'm Kurt Van Dusen, founder of Equational Applications, LLC in Grand Rapids, Michigan, USA, provider of software and full-stack development services. Welcome to this Eduonix course, Microservices using Node.js. Hi, welcome back, everyone. In this section, we're going to look at microservices versus monolithic applications. So you're probably familiar with monolithic applications. They are built all together as one unit, and that makes them the traditional application design. They're easier to understand and design because they share databases and business logic. They can share the routing and middleware. Makes data flow easy to design. But a monolithic application fails. It fails completely. So failure of a part brings down the whole. And they can be difficult to scale because you just have to throw more processor power and more memory at the problem instead of being able to break it into parallel pieces. Now, microservice applications, on the other hand, they're built out of independent services. This architecture was adopted around 2011, and the architecture does make it more difficult to understand what's going on in your application and more difficult to design. That's because they do not share databases or logic or middleware services. They are completely separate applications on that microservice level that work together to form the overall application. And that can make it difficult to work with your data flow because all these separate parts have to somehow share data and yet still be independent with their separate databases. But this structure also makes them more resilient because if one microservice fails, the rest of the application as a whole will still have some functionality. Microservices can be much easier to scale than a monolithic application. With a monolithic application, you have to scale the whole thing, whether it needs to be scaled or not. But with microservices, you can just scale that part of the application which needs to be scaled. And you can do it just by duplicating parallel clones of the microservice. So this makes it much quicker and easier to deploy when you're scaling. So this represents a monolithic application where everything is part of the same group. We have our authorization middleware, a collection of different services, and our database, all as part of the same application. So it's easy for these services to access the same data and use the same middleware. And it's very easy to understand what's going on inside of the application. Now with a microservice, we've divided the big application into smaller pieces. So we have a separate database for each service now and separate middleware as well. That way, these are totally independent services, and if one of them fails, the others will continue to operate. One of the main advantages of microservices is their resiliency, and in order to get that benefit, you have to really make sure that these services are standalone. That's very important to understand. Each service has to have everything it needs to function all within itself without relying on any of the other services. So now you should understand the differences between a monolithic application and a microservice application. and why you might want to use a microservice application when it's important for you to be able to scale quickly and to have resiliency in the case of the failure of one of your components. In the next video, we're going to learn some more about the pros and cons of microservices. Thanks for listening. I'll see you then. Hi, everyone. Welcome back. In this lesson, we are going to create an example app so that you can see a demonstration of some of the things that we've been talking about. This course assumes that you have some knowledge of Node.js, so you will need it installed in your development environment. If you don't have Node installed yet, you can refer to the Node.js website for some help getting started. First, let's make sure we have Node installed by checking our version. So that tells us we have Node installed, and that's our version. Next, let's create our directory. The name of this app will be BirdSquawk. And change into your directory. Next, npm init y for yes to all. You can create this BirdSquawk folder anywhere on your computer. This is going to hold our application. Next, we are going to install the dependencies we're going to use. That will be npm install express, cores, Axios, and nodemon. Type code in the terminal to open VS Code. Got BirdSquawk open in code, and here we're going to create a new folder, a new file, which we'll call index.js. And in index.js, we can start coding our application. Okay, let's start adding some code. First, we will require express. Next, let's create an app. Calling express as a function. And now let's use the app with JSON. Let's create an app post pathway named BirdSquawk. And we'll put our rec and res in there and our arrow function. Okay, let's go down and make the app listen to a port. We can use port 5000. Let's give ourselves a console log message. Listening on port 5000. Fix. Let's go up here and call express.json as a function. Now with our app post on BirdSquawk, we are going to use a randomly generated ID to keep track of our posts. Let's use random bytes. Require from crypto. Okay, not going to use a database in this part of the example to keep it simple. So let's just use an empty object to store our data. Now let's create our random ID using random bytes with, we'll just use 8 bits. And let's use hex. So this creates a random hex ID. Now let's grab the title from our rec body. And let's put it in our Squawk data. We're going to use the ID for the array. So we're adding this new title with the ID into our Squawk data, which is temporarily acting like a database for us. Now let's create a response. I'll tell the server 201, and we will send our Squawk data with the ID back as a response. Okay, guys, that's it for this lesson. I hope you'll follow along and recreate this code on your own so that you can understand what we're doing. And in the next section, we'll test what we've done by running Postman. I'll see you then. Thanks a lot. Hi, everyone. Welcome back. In this lesson, we're going to continue to develop our example app a little further. And we're going to start building some microservices. So you'll recall that a monolithic app is built with all of its functions in the same unit. They can share their routing, their database, their authorization. Makes it really easy to design and build. But when it comes to scaling it, it's not very easy. And if one part of this breaks, the whole thing breaks. So instead, we're going to build the BirdSquawk Microservice App. And a microservice app is built with each service being completely independent. It has to be a standalone service, so it needs everything that's required to function within the service so it can stand alone. The BirdSquawk service is going to need its own authorization middleware and its own database. The same with the Peep service. It needs its own database and middleware, and the query service. So they're not going to share any database or any other part of the app. And that way, if something fails on one microservice, it's not going to affect the other microservices, and your app will still be able to work. So let's get back to coding. Okay, let's test our app and see where we're at. We're going to use Postman. So if you haven't installed that yet, just go to postman.com, and here you'll find instructions on how to install. Ready to try running our app. So let's go over to BirdSquawk, package JSON, and let's just change this line under scripts where it says test. Let's create a script for start instead. And just erase this code out of there. What we are going to use is npx nodemon index.js. And what this will do is use nodemon to run index.js. Save. We can open the integrated terminal. And let's use the command npm start. BirdSquawk is listening on port 5000, so we're successful here. I'm opening up Postman and clicking the plus button. We're going to create a new post and enter local host 5000. The name of the path is BirdSquawk. Let's go down here to the headers section, and in key, type content type. Value, we want application JSON. Now we're ready to create our body. This is what we're sending. And here we have a little bit of JSON. Title. This is my first bird squawk. Yay, let's see what happens when we hit send. Great, it worked. So here we've got the response. This is the randomly generated ID we created, and this is the response. It sent back our correct bird squawk. Okay, so far so good. Okay, let's have some fun by going from bird monolith to bird microservice. I'm just gonna navigate to the bird squawk and create a new folder that we're going to name bird squawk service. Let's take these folder files and put them in there. Great. Okay, let's create another folder. This one is going to be peep service. Query service. Going back to VS Code, let's open a terminal for the peep service. npm init y and npm install express and nodemon. Click new folder. We're going to add index.js to the peep service, so we can start adding our code. Our Express, our random bytes. Let's create our app from Express, and we'll use our express.json to parse our JSON. We're going to create peeps by Squawk ID to hold our data instead of a database. We'll create our post and get pathways. We're using :ID in that path so that we're going to use our Squawk ID to keep track of our peeps. We're going to listen on port 5001 and we'll console log that we're listening. We're going to add in our code to create our peep ID with random bytes. And then from the request body, we're going to grab our peep. Then we're going to take that peep and get the ID of the post from our request parameters. If the parameter is empty, we're going to return an array, send back our peeps, and for our get, we're going to just return peeps by Squawk by our Squawk ID. Let's just take a peek back at the JSON, package JSON. We've got our command to run this with NodeMon in there. So we're going to open up the terminal and we're going to change directory to our peep service. And we're going to run that npm start. All right, peep service listening on port 5100. Okay, your assignment is going to be to test the peep service using Postman. And that's it for this lesson. Thanks for listening. In the next lesson, we're going to go over in more detail about microservices. Hi everyone, welcome back. In this lesson, we're going to look at async events-based communication. If you remember our microservice app where we left off, the BirdSquawk service was separate from the peep service. And so we basically have two microservices right now. What we don't have is a way for these microservices to communicate. So now let's say we added our query service back into our BirdSquawk Microservice App. And we're going to add an events bus. That events bus will work like this. When someone posts in the BirdSquawk service, it's going to emit an event that'll carry the data from the post over to the events bus, and then the events bus will send it over to the peep service and over to the query service. So that way the data can get from the BirdSquawk to the peep and the query. Our microservices app follows the database per service pattern. Each service has a separate database. So how do they communicate? They could emit an event every time something happens. Maybe the event has JSON, and when a post is made, for example, the BirdSquawk service could emit an event to the events bus, and then the event bus could emit an event back to another service, allowing for some communication. This communication can either be sync or async, so synchronous or asynchronous. If it's sync communication, that means that the requests are made directly at the time that they're needed. So let's say we have a query and we want to maybe find what peeps are under a BirdSquawk. So query service might emit an event over to the events bus. It's going to go back out from the events bus to the BirdSquawk service. And here we're going to check if the BirdSquawk exists. Let's say it does exist. It's going to emit an event back to the events bus. Over from the events bus, another event will be emitted to the peep service. So now the peep service can say, okay, that BirdSquawk exists. Let's emit a list of peeps that are on that service. So the peeps would go back out here to the events bus and then come out of the events bus back into the query service. The only problem with this is that it takes time, and it takes as long as the slowest connection. So if one of these connections slows down, it's going to slow down the whole query service. Now, on the other hand, we can use async communication, and that's going to speed the whole process up tremendously. Now let's take a look at async communication. Someone creates a BirdSquawk. The BirdSquawk service is going to emit an event at the same time that that is created. It's going to go to the event bus, and the event bus will know what to do with it. It's going to send it over to the peep service and the query service. And this JSON is going to have the data from the BirdSquawk service, and it's going to transfer that data into this database and this database. So yes, we are duplicating data, and that could be a bad thing, but in this case, the benefits outweigh the drawbacks, because database storage is very cheap, and we can get a lot of resiliency and speed from our app by just duplicating a little bit of this data. Okay, so next, let's say someone creates a peep. So the peep's created. At the same time, it emits an event that has its JSON that contains the peep information. And now that event bus is going to send that JSON event out and emit it and send it over to our query service. So now the query service will get the data of the peeps. So our query service database now has this BirdSquawk post in it. It has the peep comment in it. And when someone comes to the query service and they search for a peep, it's going to be very fast, because the query service can go straight to this database and get the answer. And even if the peep service is not working or the BirdSquawk service is not working, the user will still be able to use the query service. And that's the beauty of microservices. That's a quick overview of sync and async communication. And that wraps up our lesson for today. In this section, you've learned about the pros and cons of microservices. You've learned how to keep microservices separate so that they're resilient. And you've learned a little bit about the ways that they can communicate. Hi, everybody. Welcome back. This concludes the section 1 of microservices versus monolithic applications. So in this section, we learned the differences between monolithic applications and microservices. A monolithic application shares everything. It shares its middlewares, its databases, its services, and its routing. On the other hand, a microservice application divides everything into independent sections. So a microservice can stand on its own. It has its own database, its own middleware, and its own routing. So with monolithic applications, it's all together in one unit. It's traditional, easy to understand, easy to design. They share a database, which makes data flow easy. But when they fail as a unit, and they're hard to scale. Our microservices applications are independent, they're newer, but they're difficult to understand and design because they don't share a database, and that makes the data flow difficult. But a microservice is resilient. If one part fails, the other microservices continue to operate. And they're easy to scale because you can break the microservices into their parallel parts and only scale the part that you need. All right. Thanks for listening. This concludes section 1 on microservices.